Welcome back to the shop. Today we're back into the electronics lab because I got a bunch of these dial indicators here. It says Coventry Grinders on it. The reason why I bought them is they're actually 0.002 millimeters per division, so they're quite good resolution. The problem is, and that is probably the reason why they were cheap, all the glasses were laying in the box, and some of the, I don't know if that's visible, this is actually bent and this looks weird here. Stems are not broken off, they're just screwed out. This one moves but it's a bit stiff. I think this is the only one which works. It looks like carbide or something like that. It feels smooth, so I think it's alright. Just the glass is missing, so we try to get those back in somehow. Same with this one. This doesn't move at all. So the stem is moving, but the internals and the shaft is bent. So what I'm hoping for is getting at least 3 good ones out of these 6 beaten up ones. This one is moving a little bit, so it's binding somehow. So first we need to figure out how we're going to take them apart. I've got a few other ones which I need to look at. It's all collections from eBay, accumulated over time and didn't really look at it. This is a very nice and heavy Mercer it's a 5000s indicator. It's imperial, but it feels relatively smooth. The only problem is I don't know if that's visible here, the paint is flaking on the dial, so I don't know what I'm doing there. Maybe I look for another one which is equally cheap but has other issues. But this is a really heavy indicator. It feels like quality. It's got a number on it. I don't know if anyone knows what these numbers mean, but it says 82058, and it weighs a ton really. It's great. It's just proper quality gear. But yeah, it needs a bit of looking after. This is a Kennedy test indicator. It does work. The problem is, see where the pointer is? If we get it apart and stick the pointer back on, it should be okay to work because it does move. Obviously it was very cheap. It's a 5/10 per division. 5/10 of a thousandth of an inch. Sorry, my brain primary works in metric, so I always need to think about these imperial units a little bit. So this is 5/10 of a thousand per division. It's also quite heavy, so the more weight the better it is. Because here we have another one which is probably pretty old. It's an old Mitutoyo, 0.01 millimeters. The only thing, apparently someone did some welding or smoking experiments, so that glass plastic needs to be replaced, but that's about it. I like it. It's really smooth. It obviously needs a bit of a clean, and perhaps looking inside how it looks like, but essentially a clean and new plastic shield here, and the thing is back to work, and it's metric, so it's an old Verdict 510 imperial indicator, and it's got an interesting feature here. Rather than having the smooth moving pointer, it's got some sort of a ratchet pointer here, which is nice. It's got a very positive end stop, doesn't feel mushy at all, but as far as I can see it only travels in one direction, whereas I have a Mitutoyo which is some Chinese thing, which travels in both directions. But this is really nice and smooth here. It's small. I don't know how old it is. Plenty of patent numbers which I can't read here. Yeah, so after a clean, I think that goes straight to the workshop, because it's a really nice one. I like the point. It has seen some work in its life, but there is a lot of life left in this one. It was also an eBay find, I can't remember. It was a whole bunch of indicators which I bought a while ago, and I just put them here on the shelf because I need to look after them. And the idea is actually buying something cheap and fix it. It's good fun, and there's always something to learn. So first you're gonna figure out how this goes apart. I think let's start with the worst one, which is this one. The reason why it's so battered is there was another part in the box. It came with a nice wooden box, but there was another part in the box, and this was just rumbling around in the box, and so it was someone who packed it didn't actually use his brain. So it's interesting on this one, the scale doesn't move. If you turn those, the scale is moving with the this got a bent shaft as well, but probably we can fix that. So yeah, I think at the end of the day we may have 3, if we're really lucky we may have 4 working ones, and so that's the target. That would reflect the value I paid for. They were not really cheap, but they were cheap enough for the quality of the indicator. It's quite heavy indicator, so it's just got more mass, and the mass alone actually prevents from vibration quite a bit. So if you take one of these cheap Chinese ones, they weigh nothing, and they just shake around with the tiniest bit of vibration. So the whole thing was actually a lathe dynamometer, which is some sort of device to measure forces and deflections on a lathe tool post. This thing is so big, I have no intention to use that because I can't even clamp it on my lathe. It's basically just a nice piece of tool steel which I keep. I wouldn't do that this way anymore. Nowadays you would do that with some strain gauges and some electronics. But yeah, it was used in the old days to measure something. It came with a few nice good looking ground pieces which I can use for parallels. Well, after a bit of fiddling, we found out how it comes apart. I have the other one already apart, and it's moving again. It just needs sorting out the pointer, and the shaft is still a little bit bent. That's how it looks inside. It's all die-cast material. It's proper quality, and it's pretty heavy actually. So we're gonna take this one apart because that's the one which has no gear engagement at all. The stem is moving, so don't have a lot of trouble as well. Yeah. So, and it's got a bent shaft as well, so maybe there are some gears stripped. To get it apart, it's actually quite simple. You need a tiny little screwdriver, and there is one on the scale ring. There's one hole here. Don't know if that's visible here. And there are some little screws underneath. It's 4 around the circumference. So all we need to do is getting these screws out, and then we can take the complete scale ring off. It needs a bit of pushing because it's spring loaded, so the dial itself has a spring behind and pushes the scale forward. It's just binding a little bit, so trying to get all these little screws out. And then just pull the scale off. Well, that's at least how it works with the other one. There's something is grabbing here. There you go. Just careful not to bend the pointer. It's seen some moisture. It's tarnished inside, so. But yeah, the shaft is heavily bent. I don't know if that's visible here. So I expect some stripped teeth in there. The back cover is easy, just 4 screws here. Nope. That's the stem which moves inwards. This little plunger here is just aligning in that slot and with that clock spring here, so it returns. And there is some little teeth here on that plunger which go into that gear, and that goes inside of this die cast thing here and drives, well, has driven the dial. It's a pretty simple concept, you know. You just count revolutions here, and the spacing of this gear rack is known, the number of teeth is known, so you can figure out how many turns is how many millimeters or whatever. Apparently it looks like it's got a stripped tooth inside, so first we're going to try to bend, and that's exactly what I did on the other one. I was just bending the, I need the magnifier for that. The two possibilities: either it breaks or it works. This has been pushed in as well, so this can be a bit more of a challenge. I need to put some paper underneath. Maybe it comes apart, I don't know. There is a chance that I never took one of those apart, so bear with me. I know exactly the same as you know. The only difference is I'm looking through the magnifier, and the camera, I've got a wide angle lens. So what I'm hoping is that the whole assembly comes out of here. Maybe or maybe not, I don't know. There's tension on it. So it loosens up here, but it doesn't at the bottom. And I don't know what this screw is doing here. Doesn't really make sense for me at the moment. it seems holding the whole clockwork. These two may hold the whole clockwork. Since this is beaten up, so we can experiment on that one. See what happens if we move that stuff around here. Don't know exactly what that does, but it does not make the other thing move here. They are adjusting the whole mechanism in the housing. So to take the stem out, I'm gonna loosen those screws, turn the whole thing to the left. And I think it's also used for adjusting the backlash, and then you can take these little screws out and just pull the stem out of it. I think it's binding on a teeth. Block. Oh, it came out now. Whoops. Apparently apparently there's a spring inside, which I didn't expect. So this is spring loaded as well, so this is a bit of a challenge here. That was the reason why I was binding. There's a clock spring inside, so this needs to be wound up before assembling. I think it's to preload the gears. This is moving. See that? This is moving here. So the problem lies elsewhere. There's another clock spring underneath that one here, which tensions those gears, and this clock spring is tensioning the small dial, which is seized as well. From what I can see, all the teeth are there. So the only problem is the seized, the bend shaft. So getting these shafts straight will most likely fix our problem, and then we need to wind the clock spring. I need to figure a way to get this shaft straightened. On this one, once we bend that shaft straight, once we put that pointer straight, I think we should be good to go. That's almost straight, so the millimeters are fine. So if that gets a little bit of a clean, need some preload on this with that ring which holds the glass, the screen, that is so beaten up here. I need to bend that out a little bit. This is aluminum, so there's not much trouble in it before it breaks, and these usually just snap into place here. There you go. So, and now I'll get the scale in. So, and then just carefully bend it over, and the cover is properly aligned. I'm going to put the screws in. It should be fine. I a bit fiddly, especially if the screwdriver is magnetic, which shouldn't be the case. I need to demagnetize that. And these screws are not holding anything, they are cylindrical heads, and the ring is just riding on the cylindrical part of that screw here. Here we go. I'm gonna figure the other ones, but this thing, that's almost like new. It works. And it's got a fair bit of travel. What's that? That's 25 millimeters, 1-inch travel, which is good. It's a 0.02 millimeters, 0.01 inch indicator. So I'm happy with that one. Figuring the other. Doesn't bind. So all I did on this one was basically just bending that shaft straight, and also the pointer, because it was bent up, and that's it. So they don't come with grease from the factory, so I don't grease it. I put a little bit of machine oil on the stem, and that's it. I'm not gonna grease it. There is a reason why the factory didn't grease it, so. One back to life. I think this one is a bigger challenge, just because the shafts are so bent, and I tried to pull the pointer off with just a pair of thin pliers, or the problem is it sits so well on that shaft. I'm just battering the face here, which I don't want to do. So I need to think about that. But essentially, we should be able to get that to work as well. So what's wrong with that? That's just moving hard. So it's just hard to. It goes easier further up, so you may just need a clean. The shaft got some marks here, so I think the shaft is actually binding. So let's put a glass on that one. I can turn it around because there's no need for taking the face off here. All we need to do is actually getting a glass in here, which can be challenging sometimes, because you don't want to break anything. It's actually easier if the ring is off, so because you can put a lot more pressure on. It should be good for now. I just want to turn it around and don't want to break anything here. some moisture. The screws are rusty, so this may have seen some moisture as well. I think the shaft is bent slightly, so what we do is just move it a few times and eventually there's some grime on the shaft here. So it's getting better now. It still doesn't fully return, or it just returns slowly, and there is some corrosion on the pointer as well. So that may need a little cleanup as well. The problem is the bearing here is binding, so there's no play, so that may just need some lubrication and then it will work. By the look at it, I think it's got a ding on one side, so it's a little bit bent, but that's fixable as well. So 2 to go. Not fully finished, but we're happy so far. This one can be a challenge. Badly bent. Same issue here. Shaft completely bent. Not gonna do that right now. What's wrong with that one? This one binds. There's no reason why it should bind. It's actually hitting a hard stop here. I think it's, yeah. I'm pretty sure that's not visible on camera, but the gap here is bigger than here, so I think that stem is bent. That's bent this way because it's almost on full travel here. Yeah, that's full stop here. So what this needs is basically applying some force to bend that back down. I think I take the stem out completely and just put it between centers and see what it does, and then just bend it to the right place. Yeah. Let's have a look inside. That's the right one. This as well, the screws are rusty, so I wonder who made those. I don't believe that Coventry Grinders make some indicators. It's all there. It looks all good, it's just the shaft is bent. Probably try a drill bit or so. Bend it back. If it doesn't work by hand, we just so what I'm trying is just bending that back with some help of a drill bit. I just don't want to break it here, but it does not move. I think that needs a lot more force than I can apply with a simple drill bit. This is a clearly visible gap at the bottom and no gap at the top, so yeah, it's got a bad thing here. And this one, I think this is the only one which really works from scratch here. Scale is moving, it's fairly clean. Moves, needs a bit of oil. This one is nice. So let's find a fairly clean face for that. Get it on. Okay, this is a brilliant working one. It's got a limiter here. The travel is limited for whatever reason by this screw here. If we take that out, it goes down to 0. I should be going down to 0, but it's never been there, so I don't mind that. I just rather leave that in. So okay, we got this one almost working. It just needs the a bit of grease and probably a slight push on the stem. This one was the badly beaten up one, and I'm absolutely happy to use that in the shop because they're getting beaten up in the shop anyway. So an indicator is some sort of disposable tool. They get hammered, they get battered. This one is working as well. So if we steal the pointer from here and put it on that one, we've got, again, this is the one which needs a bit of work. This one is fine, this one is fine. We might be able to fix this one. I don't know, I'm not entirely sure what's wrong with that one. Oh no, that's the one. That's the one with the shaft, with the bent shaft. So I'm pretty sure this one could be fixed as well. So we should get at least 4 out of it, which is not a bad result. I was expecting less when I looked at it. So they get I usually oil the stems just a little bit, and that's about it. It's got a nice. So I decided to do the Kennedy as well. They should be fairly easy if you just pull it apart. It needs a bit of force. It just sticks on that ring. And I think someone did that before because the pointer came off as well. So the trick is actually getting the scale back in. There is no index on it. And with this one, like this, but I need a magnifier. I need a magnifier for that. This little thingy just needs some tweezers. Put it back on the shaft. And before you push it down fully, find out what the travel is. So this is gonna be 0 at some point. So need something soft here. It's the right thing here. So we just fuck, it's too much already. So what I'm trying to achieve is actually getting the needle exactly sitting on 0. The dial is on 0, and I think I'm pretty much there. So I just use one of these that should do it. So there is no index on the there is no index, so all we do is just push the scale back on and that's it. So okay, now it comes back to 0. A little bit of a clean, get the gunk off, and we've got a very nice Kennedy indicator. The Kennedy 300 801, made in England. I think it was not cheap. So I only have one of these very tiny Chinese ones, and I don't like the feel of it. It's just not right. That's it from the Kennedy. Yeah, I put the screws back on in these other indicators and wipe it clean, oil it a little bit, and they will go to the shop. The other ones will go to the spare bin for now. I think 3 is enough for me, and I just keep them for spares. Maybe except this one, because that's a really nice one here. It's a clean one. That's it for today from the indicators. hopefully that's of some use for someone. All I can say is don't be afraid taking something apart which is already broken. The only thing you can do is actually destroy it even more. So yes, be careful, think before you do something, and eventually you may get it back together. And that's what I did all my life, and it worked out for me. I've never opened one of these before, and yeah, you've seen what happened. There was a clock spring, yeah. I didn't think about it. Anyway, it's fixable somehow. A lot of things can be fixed with a little bit of imagination and care. Just be careful. Well, that should be for today. Thanks for watching, and till next time.